In this video, we're going to learn how to build and deploy an NFT API with features like filtering, sorting, full-text search, and relational data. The protocol that we'll be working with today is called the Graph protocol. The Graph is a Web3 protocol that allows developers to build and deploy open APIs called subgraphs to a decentralized network for indexing and querying blockchain networks like Ethereum, Polygon, Near, Ipfs, as well as a few dozen other EVM-compatible networks. The reason that something like the Graph is necessary is that by default, it's not easy to do anything beyond basic read operations directly to a smart contract. Using the Graph, we can describe the data as well as the smart contracts that we would like to have indexed by the protocol. We can then deploy our subgraph to the network where all of our data will then be indexed and served from a GraphQL endpoint, giving us the modern queries that are expected by most users in today's applications. With that being said, let's get started building. All of the code that we'll be writing today will be available in this custom NFT subgraph workshop repo that I will also link to in the comments. From here, you should be able to follow along and copy and paste pretty much everything that I'm going to be doing here from start to finish. So that way you not only can have the video to go by, but a workshop as well. So the first thing that we're going to do is we're going to actually go here and we're going to see that the first steps are installing the Graph CLI. So to do that, we can go to our command line and run this command here using either npm or yarn. And this will go ahead and install the Graph CLI. Once the Graph CLI is installed, we should be able to run the Graph command and see that we have our binary working. And from here, we should be able to go ahead and go to the next steps. So what we'd like to do now is we want to go to the graph.com, and here we're going to create our subgraph in the dashboard. So we're going to go to products, and there are two types of ways to create a subgraph. We have Subgraph Studio and we have the hosted service. Now, right now, all of the features on the hosted service are not yet available in the Subgraph Studio. So the hosted service is a centralized version of the graph, and the Subgraph Studio is how you deploy to the decentralized network. Because we're going to be building an NFT API, the day of this video, we don't have yet support for Ipfs in the decentralized network, so therefore we're going to be choosing the hosted service. So within the hosted service dashboard, we should be able to go to sign in or create an account, and once you're signed in, you should have a My Dashboard. And from here, we can go ahead and click Add a Subgraph. So the subgraph that we're going to be building today is for an NFT API for the CryptoCoven NFTs. Now, this could be really any NFT smart contract that's been deployed. And I think that after you kind of go through this tutorial, you'll understand how you might implement this same functionality for another smart contract. But I'm kind of going with a well-known NFT for reasons that a lot of people are probably familiar with this, or they might just find this an interesting project to work with. So I'm going to call this like ND CryptoCoven. You can call this whatever you'd like. And for the subtitle, I'll just give this a subtitle of CryptoCoven API. And I'm going to scroll down and choose hide because I've done a couple of these and I don't think it's necessary for this to show up in the Graph Explorer for everyone else to see. So I'm going to go ahead and click Create Subgraph. And now we're given the boilerplate that we're going to need to go to the next steps. So before we do that, let's go ahead and check out the CryptoCoven smart contract. Now, you can find this probably by Googling around, but I'm going to just go here to Etherscan, and here we can kind of see the code. And one of the things that we're going to be interacting with, like I mentioned before, is Ipfs, because the actual metadata for these NFTs is typically stored on Ipfs. So most ERC 721 contracts, which are the NFT contracts, have a function that allows you to get the base URI. And using this base URI, this is how you can kind of get the NFT metadata for each NFT. So if I just copy this and I go to ipfs.io/ipfs/ this hash / something like some number.json, then we should see that the Ipfs metadata comes back. So here we have all of the data that we're going to be indexing, and we want to make this searchable. And we just want to make it available for querying. So we have things like the description, the external URL, the image, the name, all of these things that are not available directly on the token, because the only things really available from the contract are things like the token ID and the base URI, which is this URI that we just worked with. So we're going to be kind of combining the data from the smart contract as well as from IPFS to build out this nice functionality. So now that we kind of understand that, let's now jump back to our CLI. And what we want to do now is initialize a new subgraph using the Graph CLI. So we can do that by running the init command. And we want to use the smart contract address of the CryptoCoven. So I have it available in this workshop, of course. I have the exact command that we're going to be running here. But how would you kind of get this address? Well, you would just go to the contract and just copy the address here. And this is the contract address that we're going to use for our API, for our subgraph. So here I can say graph init -- from contract. And I can pass in the contract address. I'm going to jump to a new line. I want to set the contract name as token because it's an NFT. Also want to set the network as mainnet. And then finally, I want to go ahead and say -- index events. This will actually go into the ABI and it will look for the events and it will create some really nice boilerplate for us that we're going to use in just a moment. So with that being said, this should walk us through a few steps. I can choose the protocol as Ethereum. I mentioned we're going to be using the hosted service because that's what we're going to be doing to work with NFT IPFS metadata. For the subgraph name, we're going to use the path that we have here created. So for me, it's going to be Dabbit3, my username / the name of my subgraph. So Dabbit3 / ND CryptoCoven. The directory for which you would like to create the subgraph, it's up to you. I'll probably just use the default, but if I'm within a front-end project, I often will just call this subgraph, this folder subgraph. We're going to choose mainnet. The contract address is already set. Contract name is already set. And this should be it. So from here, we should go ahead and see that the CLI will create a bunch of boilerplate for us using some of these different configurations that we set up to get started. So next I'm going to go ahead and change into this new directory that we are going to have. And I'll go ahead and open this up in my text editor. And it looks like everything was created successfully. All right, so in our text editor, we have our basic subgraph boilerplate created for us. The three main files that we're going to be working with are the schema.graphql, which is our data model, and we can go ahead and delete all of that code for now. Our subgraph.yaml, which is our subgraph configuration, and our mapping.ts within the source directory. This code is going to be our custom business logic you can think of. This is going to describe how the data that we are going to be working with is going to be essentially saved. So for our subgraph GraphQL schema, we have a main couple of entities actually. We have one main entity and then we have another entity we're going to look at in just a moment. But the entity is going to be kind of like the data that we're querying. And it makes a lot of sense to use the word token for an NFT just because we're going to be having this idea of a token with all these different properties. And now we can decide which properties that we would like to set. So by default, most of the time you're going to want to do just like at least an ID across almost everything just to have that unique identifier. But for us, we might want to kind of go through here and see what one of these or which many of these traits that we want to make queryable. So the description for sure, I would say the external URL, the image, all this stuff we want to kind of make available. We might even go down here and have some of this other stuff. So I think one of the things that we're going to be indexing is going to be this birth chart stuff. And we're going to have like the sun, the moon, and the rising within the birth chart and stuff like that. And this is really just up to you, but I thought it would be fun to kind of do as much metadata as possible. So for the token entity, we can go ahead and start setting these fields. So the first one is going to be ID. It's going to be an ID. We also want to have the token ID. We also want to have the token URI. And we're going to have the external URL. We're going to have the full IPFS path. So I'll go ahead and save that just so we can have that available just in case we need it for whatever reason. We're going to have the image. We're going to have the name and the description. We're also going to have the type. And I mentioned we're going to have like those signs like sun, moon, and rising for like Capricorn and all that stuff. And then we're going to have a field for updated at timestamp. So this is going to be kind of like giving us another way to query for our tokens. So we might say, okay, we want to query for all of the most recently updated tokens, or maybe the oldest, whatever. It just gives us a new field to kind of query for, and a new piece of data that's made available. And then we also want to now create a relationship. And the relationship is going to be between tokens and owners, or tokens and users. So a user is going to kind of have many tokens, and a token is going to have one user. So we're going to have a one-to-one relationship between a token and a user, and a one-to-many relationship between a user and their tokens. So the way that we can set that up is we can create another entity. And this entity is going to be a user entity. And here we're going to have just two fields. The first is going to be an ID, and then the other is going to be tokens. And the way that we're going to make this relationship work is that we're going to use a custom directive, just like we have this @entity directive that is recognized by the Graph tooling and the Graph protocol. We also have this @derived from directive. This allows us to describe the field from which this relationship is derived. So here we're saying we want the owner field to be the way that we associate the owner or the user to the token. And this owner field is just going to be an address. So you could think of like this query coming back, and the owner will have an ID and a tokens array, but it's going to essentially be mapped using the owner's address. So that's kind of the main configuration, but we also want to have a full text search feature built in, and we can describe which fields and which entities that we would like to make searchable. So to do that, I'm going to go ahead and kind of collapse these two entities. And here we're going to have this type _ schema _, and we're going to use this @fullTextSearch directive. And here we can pass in all of the different things that we want to configure for this full text search field. So the name is going to be the query name that's given to you after the API is deployed. So when we use GraphQL, we have these GraphQL queries. This is the name of that query. So I can type in Coven search or search Covens or whatever you want to name this. I'm calling it Coven search. And this will just give me that query. We have some basic configuration that you can kind of by standard just use the language and the algorithm set as I have it here. And then here in the include array, we have a couple of things, like I'll try to break this apart in a way that makes sense. Really the only two things to kind of recognize here are going to be the entity. So we have two entities. Which one do we want to make searchable? Well, the token is the thing that we're going to be making searchable. And then which fields do we want to make searchable? So we have all these different fields. I'm not including all of them. I'm including some of them. So the ones that we're including are the description, the type, and the different horoscope stuff. So that gives us that full text search. And of course you could expand this. You could add a search for users or whatever. We're going to have a way to query for users already built in. So you don't really need to kind of add that, but you might have some other types of full text search configuration that you would want to set up that's different. So now that we have that GraphQL schema done, we can go ahead and close this file. Well, actually, I'll just leave it open even though we're kind of done with it. And what we want to now do is configure our subgraph.yaml. The first thing that we might do is we're going to go to this entities field, and we want to map these two entities that we just created here. So we have this token entity and this user entity. Here we can just say token and user. And then this is a good way for us to describe the different entities that we're going to be indexing. And that typically will match up with your GraphQL schema. The next thing that we want to do is we want to think about the different event handlers that we're going to be taking action on. So when you are dealing with a ERC 721 contract, you have these functions and these events that are by default implemented in every single ERC 721 contract, which makes it kind of easy to work between different ones. One of the most important ones, I think, is the transfer event, and we're only going to actually be indexing that event because this actually gives us a lot of functionality out of the box. Because every time a new NFT is minted, it's called. When an NFT is transferred, it's called. And when an NFT is sold, it's called. So this allows us to index all of the NFTs as they're created and as they're changing ownership between the different users. And the only pieces of data that we're actually going to be getting from the contract from this event are the address of the sender, the address of the receiver, and the token ID. And then using that token ID, we can actually read all of the rest of the data, both from the contract as well as from IPFS. So this is a very limited number of arguments, but we can kind of do a lot with it. So with that being said, the next thing that we can look at is we have our configuration here for our address. So this is the address of the contract. The one thing that we can also configure here is the start block. The start block will allow us to define when this subgraph starts to index this data. And this way we don't have to start from the Genesis block of Ethereum. We can define the start block. Now you can actually just go to the Etherscan and you can find the transactions, and you can go to the last transaction. You can kind of like get the block there. Or let's see here, last. So we can say 135471115 and just paste that there. Or you can go to the workshop, and I have this available there as well. So this start block will just say, okay, we're going to start from this block and we're going to only go forward. That way we don't need to kind of go to any previous transactions and deal with those. So that's actually the only thing that we need to do. Our graph configuration and our subgraph.yaml is only 25 lines of code, and this is everything that we need to kind of get started. Now you can add multiple data sources. So here we only have a single data source, but let's say you wanted to index multiple data sources. You could here just add a bunch of different smart contract addresses with their own configurations, and they might all have their own separate locations for all of these things like the ABIs as well as the mappings and things like that. So with all of this set up for us, the only thing we need to do now is go to mappings. And this is going to be where we create the mappings between the actual functions that are fired here for this event handler. So we have this transfer event. We're going to be calling a function in this mapping called handle transfer. And this handle transfer function will allow us to talk to the graph node, which is kind of our database, as well as the smart contract itself. So we can talk to a couple of different things from our mapping. We can talk to the graph node, which is where we store our data, but we can also read data from there. We're going to be talking to the smart contract if we would like, or to the network. And then also we have the ability to talk to IPFS. So we're going to be doing actually, I think, all of those things in our mapping. So before we do that, though, we can actually generate some helper code by using the Graph CLI. And now that we have our GraphQL schema configured, we can run graph codegen, and this is going to go and look into our schema and generate some types as well as some nice APIs for us to work with within our mapping. So now that we've run that, you should see some fresh code generated in this generated folder. And here we have our schema and our token.ts files. And you don't have to like open those or nothing, but just know that that's where we're going to import some of this code. So the first thing that we're going to do is we want to import the transfer event, which is just going to be our type for interacting, or actually for getting the proper types to interact with the contract. And then we're going to get a reference to some APIs that allow us to talk to the token contract. So this is almost like if you've ever worked with something like Ethers.js or Web3.js, this is a nice abstraction that just allows us to talk to the network. The next thing that we want to do is we want to import some APIs for talking to the Graph node itself. Again, you can think of the Graph node as kind of like the database where all of this is being stored. So we want to have an API for reading and saving tokens and reading and saving users. So we can do that by importing the token and the user from there, and we have a couple of functions that we can call. The next thing we want to do is set a variable for the IPFS hash. And the IPFS hash is going to be that base URI that we got from the CryptoCoven contract here. So if I go to the contract and I go to the read contract, I can just copy this, go here, and this is going to be the IPFS hash that we're going to be working with. And then finally, we have a couple of different APIs that we can use from the Graph TypeScript library. We're going to have the IPFS and the JSON APIs. IPFS API is going to give us a nice way to talk to the IPFS network. And then JSON is just a helper for us to deal with JSON metadata or JSON data. The only function that we need to deal with or that we need to expect is the handle transfer function. So again, this subgraph.yaml has this event defined from our ABI, and this is also defined in the smart contract called transfer. And then whenever this function is called from the network, we are going to call this handle transfer function. And this handle transfer function is going to be getting this event metadata, which is going to be essentially the address, and the token ID. And then using that, we can first check to see if this token exists. So what we're going to do is we're going to call token.load, and we're going to be using the token ID turned into a string. And then we can check to see like if the token does not exist, we want to do something. And this basically means this is the first time that this token is being kind of created. So therefore, we need to go ahead and create the token. So the way that we're going to do that is we're going to go ahead and set the token as a new token, passing in the token ID. Next, we're going to go ahead and actually set the token ID property as well. This will just be the first instance of setting this up. We'll set the ID. This will actually set the token ID property. I think I like the idea of just putting the token ID there explicitly, because when you're working with NFTs, you often have this idea of a token ID, and just having it like that explicitly makes a lot of sense to me. Next, we're going to go ahead and set the token URI. And the way that we're going to do that is we want to combine the token ID along with the /JSON. So we want to say /13.json. And the reason that we're doing that is if we go to IPFS, we're going to see that we have like this hash / the number.json. So we just want to have that token URI available for us to kind of reference if we ever need it in the future. So what we're going to do now is we're going to use that token URI to call to IPFS using a combination of the IPFS hash and the token URI. So with this, we're gonna basically be able to read all of the data like this. And then this metadata object, if it exists, will hold all of that information that we need. So what we're going to do is we're going to do like a null check, because this is what assembly script requires of us. And, it just makes sense, I guess, if this failed or whatever, to say if the metadata exists, we want to now turn this metadata into an object. So I can say const value is equal to JSON from bytes, passing in the metadata.toObject. And then here we're going to do another null check. And we're going to say if the value exists, then we want to go ahead and get a few properties off of this object. So here we're going to say we want to get the image, want to get the name, want to get the description, we want to get the external URL. And then what we're going to do is we're going to say if all these properties exist, then here we want to go ahead and set all of those values on the token the same way that we've been setting all of these. So we can say token.image is equal to image. And then we can do that for all the other stuff. So we can say token.name is equal to name. And we can say that to string, actually. We also have the external URL. We also have the description. And then finally, we have the IPFS URI. So with those properties set, what we can now do is go ahead and get another property. The next thing we want to do is get the Coven property off of IPFS. So if I go here and I look at this information, we have this Coven property. And then we also want to get the birth chart, I believe. So we're going to go ahead and do that. And we also, I believe, are going to be getting the type. Okay, cool. So we have this const Coven is value.getCoven, and we're going to say like if Coven, then we want to continue on. And we want to go ahead and create a variable called Coven data, and we're going to turn that value to an object. And then we're going to get the type. And we're going to say if type. Actually, it's going to be token.type is equal to type.toString. All right, so we have that. And then the last thing we want to do is get the birth chart. So we can go here. We can say const birth chart is equal to Coven data.getBirthChart. We can say if the birth chart exists, then we want to do some more stuff. So we want to get the birth chart and turn it to an object, and then we want to get the sun, the moon, and rising off of that. Because again, going back to the JSON here, we can see that we have the birth chart and we have the sun, the moon, and the rising. So we're kind of getting all of those properties off of there. And then we can say like if the sun and moon and rising, actually this needs to go in here. Then we want to go ahead and set those properties on the token. So we can say token.sun, token.moon, and token.rising. And now that we have all of that stuff set, we can go down here and we're going to set the updated at timestamp as the event.block.timestamp. We're going to go ahead and set the token.owner. We're also going to call token.save. This will go ahead and save the token to the network. Next, we're going to go ahead and create a user by trying to load the user. And we're going to say if the user does not exist, we want to go ahead and create that user. So then we'll just say user is equal to new user, passing in the 2.2hex string. And then we're going to call user.save. And I believe that should be it. I think that kind of concludes all of the business logic that we need to write. And we can now go ahead and try to deploy this. So to do that, we're going to go to our CLI and we're going to run the graph auth command. And this should go ahead and walk us through authenticating because we need to authenticate our local instance of our CLI to talk to our API that we created earlier in the dashboard. So we're going to choose hosted service. And it's going to ask us for our deploy key. So if we go to the dashboard here, we have this access token we can copy to our clipboard. We can paste that here. And now we see that the deploy key is set. And what we should be able to do now is just say yarn deploy. And if everything is set up properly, then this should go ahead and deploy and we should be able to test it out. All right, so once the deployment is complete, we can go back here, and if we wait a second, or maybe even if we go ahead and refresh, we should see that this is deployed in just a second. So there we go. We see that our API and our subgraph has been deployed indeed, and we see that it's syncing, and we're given a playground that we can go ahead and start testing things out with. So if I run a query by using this purple button here, you'll see that we have defined the values that we want returned, and we see that we have all of this stuff coming back. So if I copy this external URL, I should be able to go here and paste it in and see that our information is coming back as expected. And I can even use this on the right-hand side here. This is called GraphQL schema introspection. And I can get an idea of the different properties that are available. So I can say IPFS URI, I can say image, a description, and I guess we already have the other stuff. So whatever other properties that you want are all just kind of available there. So there's the image. I can go ahead and copy that and use it here. And that's pretty nice. A couple of other things that I might want to do would be to do something like that full text search that we used earlier. So what are some of the things we might search for? Let's see here. Let's see what this sun, moon, rising properties are. So we have like Aquarius. So maybe I want to kind of do a full text search for the word Aquarius. I could say Coven search. Text would be Aquarius. ID, sun, moon, rising, image. Maybe the description and the name. And there we go. We see that we have all of the Aquarius naming coming back. So all these should have that. We can also do stuff like we want to say tokens and we want to say where. And then here we can set like a filter. I think it's some syntax like this where I can say sun is, or sun contains maybe Aquarius. And there we got only the ones where they have the sun being Aquarius. One other thing we might want to do is something like a, let me remove this here. We might want to do something like where we have pagination and order direction. So we might say we want to skip the first 100 and we want to order descending and we want to order by the updated at timestamp. Then we're kind of getting this other, sorting, and then we can just remove that even. And this is going to give us the most recently updated ones. So that's it. That kind of covers everything. And if you kind of followed along, you should see that everything that we did is kind of covered here in this workshop. So hopefully you were able to get through this and you maybe learned a little something. So thanks for checking this out. If you have any questions, check out the Graph Protocol Discord, check out the Graph Docs, check out the Graph YouTube. You can also follow us on Twitter at Graph Protocol. You can follow me on Twitter at Dabbit3. And until next time, I will see you around. Thank you.